in partnership with Texas A&M. So I'm going to start with Tony because he's here from Texas A&M and is probably the first brainchild of this, and let him introduce himself. Tony has a red shirt on, so you can see the.
Hi, my name is Tony Shea. I'm from Texas A&M University, and this ATE project we have three partners. One is Alamo College, one is Richland, the other one is Tarrant County Community Colleges. So we have collaborated and developed a few remote access systems, and a few of them are testing right now in Alamo College. One of them is FASTO system, which controlled by Adam Brady Micrologic 1000. The other one is a Navelt robot 5150, and we developed virtual panels and allow the students to record the position of robots and play back with those positions. The next one is Dr. Song. She's from Alamo College.
Yeah, hi, good morning. My name is John Song. I'm from Alamo College. So I have been working with Dr. Shea for this project for the past several years. I'm so glad everybody is here today.
Hi, my name is Dan Sherry. I'm also here at Alamo Colleges. I work with Dr. Song and Edgar, and then Dr. Shea and some of his students on the project as well. And I work here at Alamo Colleges as well.
Hi, I'm Edgar Perez, and I recently graduated from UTSA. I got a position here as a curriculum developer specialist, and I've been working with Dr. Shea, Dr. Song, and Mr. Sherry to make this project possible.
Okay, I think Richard Gilbert's here also from USF. So I think Dan's going to go through a few slides. I think you also see that being presented on your screen right now. It should say remote control of modular production systems for PLCs and robotics. Maybe we should, okay, maybe it's in the slides. I haven't seen the slides yet, so I'll let you go ahead.
Okay. So this is just going to give you a brief overview of the project. I joked with Dr. Song earlier that to present the whole project, we could be here all day. So we'll just give you a brief overview. So the first part is the 3-year integration that we've been spending so far on the project. It's to develop the PLC controlled Festo Mech Lab that you've seen there in the previous slide, the robot arm, and in the future planning we're looking at a 3D printer as well. These are all going to be student generated designs of the systems, other than like the robot arm is purchased from LabVolt. But the PLCs and the Mech Lab and the 3D printer, those will all be set up and operated by them as well as learning them. And then the student operation and evaluation of the remote systems. When we got them locally on remote control, we've evaluated the systems by going through with the students and having them do some labs and then doing the evaluations after the fact. So our integrated system using the Festo Mech Lab, the students had to work with conveyance systems, feeder systems, pick and place robots, and then they integrated 3 Allen Bradley 1100 PLCs into the project to control that system. And you can see at the bottom there, I was teaching using an approach called the integrated system approach so that they could learn all of these systems within the semester. So the integrated system using the Festo Mech Lab modular system included learning objectives of the system design. You can see that down on the lower right. The students actually created that, but it was a long process, about a 3-week process. They learned basic PLC programming, electrical concepts, which you can see on the very bottom middle picture, and then pneumatics and robotics as well. The remote access, we worked with Dr. Shea and his team up there at Texas A&M to accomplish the remote access. The MechLab system and the robot arm are local area network right now, remote access. Reason being, some of our challenges that we've had is our Alamo College IT security. We have a fairly tight security here, and we actually got flagged because we were trying to do some roundabout remote access into the system. So now we're working with them to resolve that. And then also getting our curriculum development specialist on board was quite a challenge. Dr. Song worked long and hard to do that, and I think it took about, 6 months to get him on board. So now we have him on board, I think the project will move quite a bit better. And then for future project plans, we have the 3D printer remote integration that we would like to incorporate. And of course, that is going to require, we've already got the program developed. We're looking at purchasing the 3D printer, and then of course the remote integration and the curriculum development will follow that. I'm going to go to the previous slide here because I'll show you now. We'll open up the system and show you an example of that. Maybe we'll may end up having to just go, let's just go to Internet Explorer. Let's do it. There it is. Okay, he had it up already. And so with this, you can see the robot, and I'll use the camera controls to show you the movement. Go ahead and move it. And Edgar is going to be doing the movement, but you can see we can use the camera to scroll around. Right now we're kind of looking up at the ceiling. The Festo system?
Yeah. No. Just okay.
Oh, I see.
Can you do that?
Okay, yeah.
Oh, there we go.
This is the Festo system. That is the other way. Controls don't have one.
So that's the first stuff.
Is this the Festo, like
Yes,
mechatronic
this is the-
system?
Yeah, the first stuff.
This is the automated Festo system that we have, and we're looking right now straight down the feeder conveyor that comes down. And if the part is metal, the students had to learn about proximity switches. And so first of all, we have a photo optic sensor that detects the parts there. It turns on the conveyance. If the part comes down to the proximity switch and sees that it's a metal part, it'll be diverted to our left and down into the metal assembly where the pick and place robot will put a cap onto it. And then it will be brought out to the second conveyor, which is in the foremost part of the picture. If it's a plastic base, it will pass on through the conveyance system and come down to the furthest conveyor there. And the idea for the students, and they never had time to finish it, but was to put another robot there to place a cap onto that one as well. Their challenge was to produce two products, one that had the metal base with the cap and the other one with the plastic base with the cap. That was their challenge. And we got as far as you see here now. But it includes fiber optic sensors, inductive proximity sensors, photo sensors, as well as Hall effect sensors on the cylinders that are activated. And then, of course, the 3 PLC controls as well. And then I believe we have the robot is working over here. Looks like he's got it going. Yeah, there it goes.
So,
He's got it. See my zoom. I don't see a zoom. zoom on there, but it's too big. So right now, we've got the robot arm working, and it would pick the parts up at the end of the conveyor there, remove them, and eventually the idea was to have it actually palletize those parts onto the end of the conveyor, or at the end of the conveyor. Right now, we've just got a stack of them going there. Anything else?
So what's the idea for the students in the remote part? Are they accessing this from home?
Yes, the idea is going to be for them to be able to log onto their computer at home.
And that would be this
and access
interface?
this.
This interface?
Yeah, they would see this interface for the automated system. For the robot, they would have it looks like the teach pendant that comes with the robot that comes up, as well as the camera view. And they would be able to operate either the robot or the automated system remotely from home. We are facing a couple challenges on that with our IT department, first of all, make sure they can do that. And then the other one is to have only a single student, because you can imagine if we have 10 students trying to move the camera at the same time, we have to have a method of logging on. So we're doing a login screen where they can schedule a time, and Dr. Shea's students have been working with us on that to give us like a login system where we only have one student at a time. We also have to do some pre-setup, like turning on the pneumatic system. If the air's not on, it won't work correctly. We have to make sure the robot's turned on. We have to make sure everything's working correctly before they can operate. And of course, the system's all loaded with parts.
Do you have students that can't get to campus regularly that have this particular need? So what was the kind of driving force for doing this remotely?
I think there's two things. Number one is what you just mentioned. Students that can't make it to campus or can't afford to come take the classes. And so we have curriculum on the iPage that we've set up. We have all of the curriculum and everything there for them so they can do those lessons online before they access these. And then the other option is some of the high schools locally can't afford things like the 5150 robot or the MECLED systems. They might not have the budget for it. So this gives them the opportunity in the classroom. They could access this remotely from the classroom and use it as a learning lab for their students without actually having to purchase the equipment.
So, could you tell us a little bit about the program that this course is? This is one course, or what course is this used for, or what bunches of courses is it used for, and what's the degree program if it's in a degree? Is it in a degree program?
It's actually part of our pipeline. We do have some of the students that are coming through that are college students that are doing degree programs in the instrumentation, and the other students are coming from our Alamo Academies, which is a pipeline, a high school pipeline that feeds into the system, and they come in either robotics or PLC courses, and when they come through there, we integrate this system into there, and while they're learning about PLCs and robotics, they're also learning how to remotely operate this and evaluate it for us as well.
Is that a dual enrollment program within the high school?
Is that dual enrollment? I don't believe so.
Do they get college? They get college credit and
They get college credit, they
and
get
high school credit.
Yeah, so basically this is a 2-year program. So our courses are focused on forcing into the second year. So after we finish develop the curriculum, including these two, they get not only the high school diploma but also the credit, 30 credit from Alamo colleges. after they graduate, if they decide to get enrolled in other colleges, they don't need this 30 credit. They got this 30 credit already.
Okay.
And they have the opportunity to transfer that into the college programs. And like the class that I'm teaching right now, the robotics course that I'm teaching right now, which is part of this, we have 10 students in there that are going to become part of our AMT program, our Advanced Manufacturing Technology program, which is with industry partners around San Antonio. And so they're going to be going into there, and some of them will go into engineering programs, so it just depends on what path they decide to take from there.
Okay. So Tony, can you tell us more about your role in this project?
Sure.
Slides.
Okay. Hello. My name is Tony Shea. I'm from Texas A&M University. So when we start this project, the intent is to help to work with 2-year colleges to develop curriculums and laboratory exercises. So the principle behind the remote labs is really consists of a few components. The very first one is your main login page. And then in that main login page, half of the page is a webcam that presents the real-life images of the automated systems. The other half of the web page is really the control panels where you can remote access to the systems. In this case here, you just on and off to turn it on the systems. And also, in the case of robotics, you will have a virtual teaching pendant here. Here you have the option of moving every single joint of the robots. And then you can also record the positions. You can do the motion planning of your robot first to see how many points the robot needs to have. And then you can use this virtual panel to move each axis of the robot. And you can see the movement of the robots from the webcams. And then you can save the positions. Now say you have 3 points. So you go through that process. You move the joint, move the links, and you save the positions A, B, and C. And later on, you can play back using the virtual panels. And then after that, you can see your robot actually go to A, B, and C and pick up the parts. And perhaps there's a D position which you drop the parts off. So the difficult part often is on the control panel part, which is on the second page of the second half, the main web page. In this case, for this robot, we have to buy the SDK, we call it Software Development Kit from Levolt. And we use the function and library developed by the SDK, and then we have to send those series of commands. Whenever you click on one of the buttons, in fact, you are sending the pulse, the position of the motors, which motor to move, and then at the same time to move how many rotations. And that's what actually had to take place behind the scenes. But on the main web page, all these software components will compile into executable files. So when you are in the login page, you actually run a executable file. And that executable file is waiting for a data file that contains, first one, which motor, second one is how many rotations. And so for every single equipment, we had to figure out the channels to communicate from the web page to a controller.
So do you have students at Texas A&M do you use the same system there for your classes at the university?
So the way we develop and design this system is we work with partners. In this case, is Alamo and also Richmond. We look at the existing equipment they have, and then we try to get one we can have and we can develop in A&M. And then once we develop, we test it out by our students first, and then we invite Dr. Song and other folks to attend the workshops, one-day workshop in A&M, and then we demonstrate how it works. At the same time, we load all the software into the servers. And then after that, we will have a follow-up visit to the Alamo College to resolve some of the issues.
So the question I was asking are, and students enrolled at
Yes, so my students
in your own PLC or is it a
Yes.
mechatronics course?
So in my class, it's called Manufacturing Automation Robotics. So we also teach programmable logic controllers. So the students were able to use systems which on our server that running the automated systems as well as the label robots. And we do that. We have a larger student pool, so we're able to test out the students every semester, about like 40 to 50 students.
Okay. So can they access it at the same time? This is a question that came up for Alamo.
We are working on the scheduling systems that allowed the student to get on the web page, just like Google Doodle. You can get on the web page, and then you can pick your slots, and there will be a timers. In fact, the timers is introduced by the 3D printers. Last time, when they visit us, you can specify the time slot which you want to use the equipment. And then there will be a clock, you are counting and give you a warning how much time you have left. And then in the end, when time's up, you will cut it off.
Okay. Gary, I think you're on. Gary and his group at College of Lake County has developed a really small, low-cost trainer we looked at a couple of months ago, I think. Any chance, Gary, you could get that video up and just kind of show it? So,
Well, I can try to do that, Marilyn. I don't know exactly how to do that.
get the link, and I believe we just have to turn ourselves off of presenter, and then you have presenter rights right now. So you would,
Okay.
we'll walk you through that once you get it on your screen, if you want.
Okay, give me a couple of seconds here, Marilyn. Okay, I think I have the web page, and then we can run the video from there. So just kind of guide me on how to get what's on my screen up on everybody else's. Hello?
Hi, Gary. This is Daniele. In the bottom of your screen, if you see the little blue circles, one is the camera, the second is the microphone, the third is a little screen.
Yes.
Go to that.
Okay.
Now you can choose present programs or present desktop. Either way is going to work for you.
Okay, share screen.
Sure. You can do that too. I will say present programs, and you choose the program or the video you want to share.
Okay, so I see present PowerPoint file.
So it's not a PowerPoint, isn't it? It's a video.
No. It's a web page actually.
Okay, you can do present desktop if you want to. It was gonna work either with present desktop or present programs. The first or the second option.
Okay. Share one or more programs.
Exactly. So you pick that, just pick the program that you wanna present.
I only have 3 programs that come up there: Skype for Business, Skype Meeting app.
And what you want to present, you don't see it?
Oh.
Okay, so then go to present desktop. And you have to have it open then.
Okay, I have it open.
Okay. So choose present desktop and just manage to do that.
I don't even have a, let me go under more. I don't even have a present desktop. On my options, I have share screen, share program, present.
Okay, share
PowerPoint.
screen, that would work too. Share screen.
Okay. Share screen.
Yes. There you go. It's loading right now.
Can everybody see that?
Yep. You're on. Good job.
Okay. So just very quick, can everyone hear me?
Yes, I can.
Okay. Just very quickly, we have a ATE NSF grant, and we're building some low-cost trainers to be used in high schools to develop some dual credit pathways into our associate degrees. And these low-cost trainers we're defining as trainers that are under $1,000 that will accommodate 2 students. And the reason we have chosen this pathway is because it's very costly for high schools to invest in equipment for the teaching of mechatronics. So we're trying to make it more affordable for them. So the trainer that you're looking at on your screen right there is actually 3 subsystems combined into one trainer.
Can everyone see Gary's screen?
Yes,
I can see it.
Yeah.
Yes.
And let me show you this video, and it might explain it a little bit better. This is an instructor in Maryland, Tim Callahan, who actually designed the trainer.
All that, sorry. Oh, there it is. Oh, that's a little guy. Gary, are you talking? I can't hear him. I think he's walking through it. Yeah. There's a little conveyor. I think they used a click PLC.
Yes.
Okay.
Oh, I see. That's a good connection for me.
Nope. You make a 3D print.
Yeah. I think they do the plastic or colors. I can't remember. This is probably just because the connection here. I can send you guys the link.
Did anybody record this session?
Yeah, they did.
They did?
Gary, you may be able to talk if you want and explain what you are doing.
Okay, a number of the parts, all those parts that you see in white, those are all 3D printed parts. So the parts were designed so we could actually have the high schools build these trainers if they had a 3D printer and reduce the cost on that. In addition to the trainer, Tim is working on a very detailed lab manual that can be used in the high schools for students to conduct lab activities, as well as there's a fair amount of open source material in the lab book that supports the theory and the practical portion of the training. And each of those modules that Tim was referring to can be removed very easily. So a student could work on the puck dispenser, maybe write the program, and there'll be lab activities specific to that puck dispenser, and then the candy dispenser, and then the storage module, if you would, that sorts the pucks. So those are all removable and then can be combined into one system. But we felt as important as the equipment, of course, was the curriculum that high school faculty and students could be used to support that. And this has gone over very well for us within our grant. We showed this off at the PI conference, NSF PI conference in October, and it went over very well. We are also conducting annually, we have a professional development component on this for high school faculty. It's held in Jacksonville, where we bring them in and we essentially show off the trainer, and then we have a week-long workshop around the trainer to make them, you know, kind of familiar with it and learn some of the ins and outs of the technology.
Yeah, so the first workshop last summer, the teachers actually worked specifically on PLCs, the PLC portion. They did some wiring, and they did some programming, and they worked a little bit with the Festo equipment at that college. You can't hear me. I'm not gonna mess. No. And then this summer they'll be working more with these mechatronic components added onto it. So the second summer, this July, we'll have some of the first year teachers come back for a week, if they can. They're supporting it financially, so it's a time issue. And then they'll run another week of beginner high school teachers. You know, they'll be their first time at the session. So,
but if this is something you're interested in, this web page is just put together, and it has all of the drawings for each of the modules. It has all of the files for the 3D printed parts, and there's also some laser cut acrylic parts that are part of the trainers. It has the electrical and the wiring schematics. So basically it's been organized here under the theory that a high school, and they could do this with their students, actually build the trainers. And again, depending upon how many students they're serving, we recommend 2 students per trainer. So they could actually build the trainers as part of an activity and then have the trainers for their use in their curriculum. And the goal here that we're shooting for is to align this with a dual credit course offering within our associate degrees. And like I said, it's taken off very well, and we're pretty proud of it.
Right, Gary.
There's curriculum down here that is kind of in progress, but the first manual is completed on the PLC, and we do use a Click PLC, which programs similar to a Allen Bradley, but you can get a PLC for under $100, and the software is free from Automation Direct, and it's a good little processor to introduce high school students to at an affordable cost. So that's kind of what we're doing with the low-cost trainers. Any questions?
Thank you,
Can you
Gary.
hear me?
Yeah, go ahead.
Yes.
Hi, this is Don Dagan. I'm from Thaddeus Stevens. This is the first time I've made this call.
Okay.
And I've been like vaguely paying attention because I've had students in and out. But anyhow, so I teach an associate's electromechanical or mechatronics. And I was really excited when I saw this coming across the wire. And we have a capstone with our college students. And I assigned 3 of my students to work on this. So they've been tracking with your documentation and stuff.
Oh, good.
And my intent, I liked all the things I just heard about what you guys are intending. My intent is to maybe have 7 or 8 of these for a class of 25. We tend to work in teams of 3, unfortunately, but
Okay.
I'm pretty excited about it because it's very tangible. It's everything I've seen so far is done really well. We 3D print a bunch of stuff, so you guys did well there. Probably my biggest challenge so far has been the laser cutting. And we have a makerspace on our campus, and theoretically I have access to that laser, but in practice that's been an issue. So we're currently either hacking it or 3D printing it, which is not a great solution, but
Well, you know, something else you could do, because it's kind of a challenge for us too, and I think for high schools it'll be even a bigger challenge because of the cost of a cutter. You could make it out of like, the bases out of like 1/4 inch, maybe masonite board or something.
right, and that's what they originally were talking about. And then I said, well, we have a laser cutter at the makerspace. Let's get them to do it. And we went through getting the files the way they wanted them, different layers for engraving, and then they've gone totally quiet. And I have to admit, I've not been following up with them. But one of the other interesting things I'll tell you, I wasn't really aware of open builds. And it turns out they go to some of the same events I go to and stuff. My students got that actuator, the lead screw actuator.
Yeah.
And it's interesting because they said, oh, the video instructions are lousy. And one of them put it together. And of course, this is their 4th semester. So, you know, I expect them to kind of have their wits about them. And it wasn't, it had some slop in it. It wasn't, so I watched the video and I said, you know what, this video is really good. In fact, I'm going to use it with my freshmen when I first introduce actuators. And you guys need to go back and tear this apart and put it together the way Open Builds tells you to put it together. And you learn about preload and you learn about those eccentrics. And so the cost is exciting. And then the fact they're putting an actuator together and learning how all those little nuances stack up. I'm pretty excited about the whole thing, and so far it's gone good. So hopefully the next couple of weeks they're actually programming it and running it.
Good. And you know, at the College of Lake County, we're building 8 of them as well, and we're going to use them in a kind of not the final capstone course, but kind of a capstone experience along the way. Because
Okay.
there's an awful lot in there that you can really do.
Oh yeah, no doubt.
We added, I don't know whether you noticed we're making some modifications to this. We did add another sensor into the puck station.
I'll have to check if they noticed that.
Yeah, it's in the final prints here on this web page, just to check, see if a puck is present. And then we added a sensor on the candy dispenser to make sure there's candy in there before it dispenses.
Yeah.
So, like anything that was engineered and designed, there's some bugs in it that will have to be worked out, but
that's
overall,
actually good.
yeah, the students can, it's another experience for them as long as it's not too frustrating.
Yeah, I would like to see about 30 of these. Like, I just think this is where we should all be heading. I'm very excited about what you guys are doing.
Well, and something we've done with the PLC trainer, we kind of lent some of those out to the high schools that they can get their hands on and get their students involved with it. It still belongs to the college, but it kind of gets it out there right away. Because, to tell a high school faculty member, hey, you can go ahead and build these things, that's sometimes easier said than done with resources. So if you did build a bunch of these and you wanted to loan a few out to your high schools, that might begin to build some bridges into your program.
Yep. My students, I make them do a budget and stuff, and I'm pretty sure we're north of 1,500, close to 2,000. So I'm not sure why that is yet, and we'll kind of do some accounting by May and figure out. And we kind of knew going in that we were going to be over the $1,000 mark. We thought we'd be around 1,500, but I haven't delved into the reasons why behind that yet.
Yeah, and there's some things you can cut cost on, like that light tower. You could go with a smaller light tower. I think that light tower was around $100.
Yeah.
And there's some shopping around you could do to further cut the cost.
One of the things, I'll probably go the other direction. It's so much of an effort to place POs in my system. I'll probably try to consolidate where we buy stuff from in the future.
Yeah.
And I'm not a big fan of Amazon purchasing, so the sensors and stuff, I'll go to probably Automation Direct for that and stuff like that. So
yeah. Well, I'm glad to hear that you're using this and are excited about how it's working with your students.
Where are you located in Maryland?
No, I'm in just north of Chicago.
Oh, okay. For some reason, I thought this was coming out of Maryland.
Yes, it is. We're working with Anne Arundel in Maryland. They're outside of Baltimore.
Oh,
and
okay.
then Florida State in Jacksonville. So we have 3 colleges working together.
Okay.
So this actually, the design came out of a faculty member in Baltimore.
Okay. Yeah, I'd like to meet him. He's only an hour away. I spent a lot of time down in Delaware and Baltimore, so I'm just north of him in Pennsylvania. So please consider me for any future activities like this. And there's no doubt in my mind this is the type of thing we need more of. Not just this one idea. We should have a bunch of different similar, and it has enough comparison to industrial. I like the approach, the 3D printed, the low cost. There's just a lot of good things you guys are hitting.
Good. And you have this website.
I
Is
do.
that correct?
I do, yes.
Okay, good. Because as updates are being made, this is kind of the portal that we're, at least for now, that we're going to put them in so they can get out to the folks that are using it.
Yeah, I tend not to do as much as I'd like to during the semester. If I have 7 teams, sometimes I don't get around to tracking with each team, so I put a lot of burden on them to be tracking that. But I'll have to ask them if they noticed that puck update or the hopper sensor. So
well, good. I really appreciate your feedback.
You bet.
I really do.
You bet. We'll see how it's going, and then I'll advise everybody when we have ours live and running.
Okay, great. Thank you.
You bet.
All right. So I had a question for you, Gary, but I've now lost it. Oh, is Tim's contact on that website if you wanted to get in touch with Tim and go visit?
Yeah, it's, you probably can't see my cursor.
I
It's
see
right
it.
above the picture. Tim Callanan, there's his email address.
Yeah, I see it. I'm also on that Google forum and stuff.
Okay, good.
Okay, great. All
If
right.
you
Well,
get a chance to meet Tim, he's quite a guy, I'll tell you.
yeah, really.
Well,
I'll make a point of emailing now, and then when we cross paths, we'll try to track each other down.
So, let's see, what are we doing for time? We have a little more time. I don't know what happened to Dan Horine today, but I know they had a snow day in Virginia yesterday, so maybe they're still snowed in, or snowed out of school. But he is also building one of these. I don't know if you know that, Gary, but I think he started building one of these trainers also. So
he had said that on the last or the second to the last call.
Okay. So I know there's a couple. And then recently, I heard again somebody who was making a small trainer, but I think it got patented. Or they were going to patent it. I can't remember where it came from. I'll have to go back and look. A small, I say low cost because that's the vocabulary you've used in your project, but a small trainer kind of for the high school audience as well. So I have to go back and find that and see if I can send that reference out also.
What kind of licensing did you put on that web page?
You know, I don't think we have any licensing on there yet, but it's going to be creative.
Yeah, I would put that up as soon as possible. That'll get my hackles fired up. I hate when people, if you know who's copied that, I'd like to take them out.
And we kind of threw this, or Tim kind of threw this together just to get it out there.
I think it's well done considering, but yeah, I would throw up that Creative Commons license and no commercialization. Yeah, I think we as a community should really try to defend efforts like this and make sure people don't start trying to profit from it.
Yeah, that's a good point, because we also have to put something out there on NSF, in terms of a disclaimer as well. And those are
actually
things
NSF is the bulldog that can go after anybody trying to commercialize that.
Yeah.
And I'm guessing whoever that is probably already making money off of other NSF stuff and will back down pretty quick.
Yeah, but that's an excellent point. We need to do that. It's one of those things that, we know we need to do it, but we just haven't done it. But we need to.
Just another aside, because there's so many 3D printed parts in here, Open Builds is going to be at an event this weekend in Goshen, Indiana called MRF, Midwest Rep Rap Fest. So it's all 3D printing stuff. And I'm hoping they're going to come to East Coast Rep Rap Fest, which will be right near your Tim Callanan's. It's going to be in Bel Air, Maryland. So that's in like the third week of June. But I'd love for somebody, I've already recruited my students, but if the people from Maryland, Tim's program, want to collaborate and do a presentation of this at that event, I think it would be really good exposure for everybody.
Okay. Could you send me send either myself or Tim an email on that?
Sure. Let me, is yours on the website as well? I see Tim's, but
mine is G Morgan, Morgan.
Hold on a second. Morgan.
G Morgan.
Yep.
At CLC Illinois. .edu.
I'm sorry, Charlie, Larry, Charlie, CLC?
Yes.
And then what?
Illinois. .edu.
All right, you'll see those links for this weekend's event and then the one coming up in June on the East Coast.
Okay, great.
I just typed it in the email in the chat box also. So I'm going to close this out. I think next month Dan is talking about some conversations about industry partners and how we use them and stuff like that. And that's all I have unless someone else has a question or a comment.
You know, I just had a question about the work that's being done in Texas with kind of the high school feeders. And my question is, before they're able to do any remote access of that Festo system and that robotic arm, how much pre-information, if you would, or theory do they need to be given before they can actually get in and make that robot do some moves?
With the students that we're working with at the college, they start in the end of their first week with the just basic familiarization. Now, with the online students, we haven't done it yet, but we're going to make it so that they have to at least completed the fundamentals of the curriculum that we're putting out before they can access it. So they'll have to have a fundamental knowledge of robotics in the system.
And also, this is like our, this course happened on our second year. So on the first year, they have to take several courses already. So they have to take several prerequisite courses already, so they can take this course.
Okay.
Courses, PLC, I think. I don't know.
Yeah, no. Actually, the let's see, it's like fundamentals of fluid power,
Okay.
or fundamentals of DC, AC. Yeah, a little bit of motor. So because we use a step motor to control the robot, something like that. So they should know a little bit of everything already. But on our course, we still give them an overview first. So give them an overview for everything, and then they can just work on the.
And the high school students that will access it remotely, they're in an advanced manufacturing program.
Yes.
At the high school. So it's hard to say what they've learned because they learn at a different rate, kind of different packages, right? But it must be their senior year students that would be accessing that. So they're students that are enrolled probably, Gary, in programs like the one you're getting ready to set up with your teachers.
Okay.
So in their last year, I'm presuming, is when they would probably get do this access. So depending on what they learned when, they should have had some fluids, I think, some PLC, motors, AC, electricity, and stuff like that before they do this. And like they said, they didn't emphasize it too much here, but they built an online curriculum that the remote students would use. So I guess instead of going to class, they're going to go through modules online that have been developed. Is it with your grant project?
Yeah.
With the grant project. 2 courses.
Wow, that's really nice.
So there's this online curriculum that theoretically they'd be prepared for from these prerequisites or what they've learned before, and then they'll be able to take this 100% online, I guess, right?
Yeah.
Yeah.
Nice concept.
So I just thought it was really interesting because it's kind of like the next step from them having those nice little trainers in the high school, for them, towards the end of their high school, being able to have some kind of remote access like this project is doing. We can look forward to as some kind of next step dream.
Yeah.
To really get some of those high school students going earlier.
Yeah. So several high schools actually bought the lab vote robot already.
Oh, okay.
Yeah, they just kind of
visit our lab and then see what type of robot arms we use, and then we bought the same arm. So the next step, we are also introduce like the idea to them, to the high school.
Okay.
So we have a partnership with them.
Okay. Okay. Great. Great. Okay. Well, our time's up. I guess I'm going to say goodbye to everyone, and I'll see you next month. And
Marilyn, Ed Bass here. Tried to send you a note about this, but sorry for walking on late. But I do have a question that that can be left on the table for folks to communicate later to me. I'm looking for a keynote speaker for our dissemination conference in August, and I was just wondering if anybody had any suggestions on that. If so, could you email me at eabass at Edward Albert Bass at HagerstownCC.edu. So we're looking for possibly even more than one keynote speaker for this day-long conference to talk about our grant, what we accomplished, but also, the things that still need to be done and what industries, unmet needs are.
who's the audience?
We're inviting high schools, students, and of course industry members.
Okay. Okay. If you have, details about the date and that kind of stuff.
I could send it out to everyone. How about I do it that way?
Yeah, that would be great.
Perhaps some of you can even attend. All right. Thanks, Marilyn.
All right.
Thanks for setting this up, Marilyn, and thank you, Texas.
Thank you.
Yeah, thank you. All right. Everybody have a great weekend.
Bye.